Alright, session 2 of lesson 1. So this is Tuesdays. Now we're developing our understanding a little bit more. Yesterday we were exploring. Today we're developing our understanding of rigid transformations and the properties of them. So remember, we're moving them, we're moving the figures to new locations. We are changing their orientations by either rotating them or reflecting them, but we are not changing their size yet. So the first thing we're going to do, we're looking at these two figures, and they've got big old long names, but it's PQRSTU, PQRSTU, and it's a transformation of this figure. So this pink one's the image, blue one's the original. So we need to figure out, is this image a translation, reflection, or a rotation? And we're going to explain our reasoning here. I'm going to use my purple pen. Okay, so, well, it didn't just slide. So remember, the translation is the one where you slide, and it didn't just slide because it's got a new orientation. It's flipped. And the one that's flipped is the reflection. Okay, and that's really all there is to it. So it's a reflection because it's flipped. You could even get fancy and say the reflection because it's flipped over the line of reflection, which was right in the center. The reflection because it's flipped across a line of reflection. Okie dokie. So we're going to draw an arrow to show how it moved. And, oh, we already added the line of reflection. Look at that. We're such diligent students, us. Okay, so there's a few ways that you can draw this arrow. Maybe just a little boop. Look, it flipped. I feel like putting it up here would indicate a rotation, and putting it straight would indicate a translation. So I'm going to do a little arch line, but however you did it is probably fine, because I know what you mean. Okay, so now we're going to look at this shape, and we're going to identify the corresponding parts. Remember, corresponding basically means like the matching ones, the one that goes with it. So when figures are the same shape, you can identify the corresponding, so the matching parts between the figures. Angles in the same relative position are called corresponding angles. Sides in the same relative position are called corresponding sides. When you name figures that are the same shape using vertex labels, remember vertex means corner. In fact, let's add that little note for ourselves so we don't forget vertex. Oh, I want my highlighter. Vertex means corner. So we've got our vertex labels because we labeled all the corners. It's important to use corresponding vertices. Vertices is just plural for vertex. So this is a vertex, this is a vertex. D and C are vertices. Vertex D, vertex C, they're vertices. I'm eating my words here, but yes, vertices, that's two. So we've got the figure, the image. It's the image of the original. And we're going to identify the corresponding parts. So, okay, we've got line AB. The little line across the top means, we're looking at a line. So line AB. I'm going to change over to orange. So line AB, well, what's its corresponding line? PQ. Line PQ. PQ. You could have done QP. It doesn't matter. It's the same line. Just which way you're labeling it doesn't really matter. Alright, then we've got, change colors again, because why not? EF, well that's going to go with TU. TU, and we want to remember we're labeling it as a line. Then we've got RS, so RS goes with DC, or CD. CD. There we go. You probably do this without me. You can go ahead of me and skip in this video if you want to. It doesn't matter to me as long as you get it right, right? Okay, so now I've got the up line, line UP, Let's do that one in yellow. UP. Let's put that as AF as the corresponding. AF. Oh, yellow didn't show very well. That one's smart of me. Whatever. And we've got BC. BC goes with QR. QR. And then we've got the last one, ST, and that goes with DE or ED. Doesn't matter. Ta-da! Look at all those corresponding lines, the matching sets. Okay, now how do you know the lengths of the corresponding sides compare? How do you know? How do the lengths of the corresponding sides compare, and how do you know? Okay, well, how do they compare? So we've got, let's take BC and QR. BC and QR, for example. Change over to my yellow highlighter. BC and QR. Well, how do their lengths compare? They're 1 unit, 2 units, 3 units, kind of there. 1 unit. No, I don't want extra tools. Thank you. 1 unit, 2 units, 3 units, 4 units, and this one is 1 unit, 2 units, 3 units, 4 units. They're both 4 units long. And I know because I counted them myself. They are, well, you do cursive just to mess with you, both 4, oops, bad cursive. Maybe I should stop that. Units long. You could say, okay, we could do this 2 ways. We could do it the simple way and just say I know because I counted them. I'm going to go the academic way and say I know because a reflection is a rigid transformation. Rigid transformation. Actually, I counted them as probably a better answer, but you know, whatever. Sometimes we just want to be fancy. Okay, so in the same figure, in the original image, in the original figure, line AB is parallel to FE. Let's look at that. So we've got, and what color did we do those? AB and FE. So this orange one and the blue one, they're parallel. You can write that using a parallel line notation, which is just 2 little parallel lines. Isn't that convenient? And keep it simple. There's the notation for parallel lines. So in the figure, in the image, I should say, PQ and UT are also parallel, right? Now, are these the corresponding lines? Let's see. We've got AB and FE. We've got PQ and UT. They are also parallel. That is true. And how can we tell? Well, again, it's a rigid transformation. So if they're corresponding, then if one set is parallel, the other would be parallel because they are corresponding within a rigid transformation. But let's do the opposite of what we did before and keep this one simple. They are going the same direction. There we go. They go in the same direction, just like the first ones were. Keep that answer simple. Alright, now we're going to look at the other pairs of parallel sides, and what do you notice about the corresponding ones in the image? Okay, so let's look at these. We've got, okay, so AF is parallel to BC. Well, is PU parallel to QR? Yes. ED is also parallel to the same ones, and TS is also parallel to the same ones. DC, FE, and AB are all parallel to each other. RS, TU, and QP are all parallel to each other. Isn't that interesting? So, what do we notice about the corresponding pairs of sides in the figure? They're also all parallel, because nothing's changing, right? They are also all parallel. Can I use parallel in cursive? Parallel. Yay! Period at the end of our sentences. They are also all parallel, because if one thing's going to be parallel, the corresponding one's going to be parallel. That's how that works. Okay. Now, we've got some more rigid transformations over here. We've got now our original figure, this blue one, has 3 transformations that we're going to look at. So, figure ABCYE. Let's see, which one is that? ABCYE. Okay, so that's the first image. HIJKL, that's the second image. And PQRST, that's the third image. So 3 images for this VWXYZ. Identify each as a translation, reflection, or rotation. So remember, translation is the one that slides. Reflection is the one that's flipped. And the rotation is the one that's turned. Okay. So which one is the one that just slid over? Well, number 2. I'm even gonna cheat a little bit, and I'm just gonna put 2. These are mostly for our practice. We don't have to be that thorough with them. The one that's flipped, that's number 3. And this one is turned over on its side. It's changed its orientation, and that was circled one, but not the other 2. That's terrible. Okay, there we go. Now they're all circled. Okie dokie. So in problem 3, we've got PQRST right here, the one that is the reflection, and we're going to identify the corresponding angles, and we've got this little angle symbol right here to help us out. So we've got angle V corresponds to, let's see, angle P. Angle P. Let's see, we've got angle S. Ooh, it's a little hard to see it up here, isn't it? It's the bottom up here. Okay, so that's angle Y. Angle Y. And we've got angle Z. And that goes with T. Then we've got angle X. That goes with R. We've got angle Q. Let's see, where's Q? Oh, Q's right here. There's Q. There goes the W. There you go. Alright. And how do the measures of the corresponding angles in problem 4a appear? How do they compare? Well, it's a rigid transformation. So they're going to be the same, because we're not changing the shape. We're just changing the orientation and location of it. It's a rigid transformation, so they will be the same. Smiley face. Hey. Okay. Alright, we've got just this one little section left, and then you're on your own for the green pages. The green pages are your things to do. Okay, look at the 2 model-its. Okay. So we modeled it here, and we modeled it here. See what it says model it corresponding angles. How can corresponding parts help you determine that an original figure and its image are the same size and shape? Okay, so, well, the corresponding parts. Well, if they're the same, how can corresponding parts help you determine that an original figure and its image are the same size and shape? Well, if they measure the same, they are the same, right? You can measure them both. I don't know if you have a protractor handy for the angles. We could write this out a little more robustly by saying if the corresponding sides and corresponding angles all measure the same, then the figures are the same size, size and shape. Alright, so now we're going to transform JKLMN to make an image. We're going to label it A, B, C, D, E. And draw and label it, and we're going to identify the transformation you used, then use the corresponding parts to show the figure and the image are the same size and shape. Okay. So, you know what's the easiest one to do, don't you? The translation. So let's do the easiest one. We're going to translate this figure just a few. Let's translate it. Let's see. 1, 2, 3, 4, 5, 6, 7 units to the right. So J has now become A. And let's see, this is 1, 2, 3, 4 spaces over. 1, 2, 3, 4. K has become B. And I can make a line there. And then we need to go up, well, I guess down 2 and over 1. Down 2 and over 1. And that's C. And then we need to go just up 1. And that's going to be D. We're going to go over 2, 1, 2, and that's going to be E. And there we go. We've got our beautiful translation. Alright, now we need to use the corresponding parts to show that the figure and image are the same size and shape. We don't have to do all of them. I mean, you should do all of them, but we're not going to do all of them because, you know, that's a lot of writing. So let's just look at a couple of them. We're going to do line JK is equal to line AB. We've got line KL is equal to line BC. You could say that angle M is equal to angle D. Those angles right here are both equal. You could say that line NJ is equal to line EA. You could do a whole bunch of things. You could label every single angle, every single corresponding line. They're all going to be the same because we did not change the size or the shape. We just moved its location. We just translated it and slid it over. Okay, so excuse me. Now you're going to do the practice part. And this is we just finished page 10. So you're doing 11 and I think just 12, right? Yep, just 11 and 12. You're going to take a picture of those for me when you're done and upload them to Canvas. And if you need any help, you know how to get a hold of me.